Hi, and welcome to this new Zoom into Opusmodus. Today I would like to play a bit with Opusmodus to do a short section for Pierrot Ensemble and vibraphone. So I will use that template. So that's a basic template for Pierrot Ensemble, but it's a personal template, so I'm using a Vienna symphonic library instrument. So the first things I can do is to load my Vienna Ensemble Pro instrumental ensemble. So you can do that directly from Opusmodus, as you can see here. So that's my ensemble. And now I will use that template. So actually it's empty, as you can see. But first I will generate a texture. My idea for this example is to generate a texture for Pierrot Ensemble and map some harmony extracted from the famous SACHER name. Pierre Boulez used it, and Lutoslavski and many other composers. You can do an hexachord from this name, SACHER, S-A-C-H-E, and R is Re, So my idea is to use this famous hexachord to generate some harmony for a Pierrot Ensemble small texture. So now I need the texture first. So for my generation, what can I do here? I will use a length reservoir here, specify the number of cells I want. I have a variable new max for maximum number, with the length of my reservoir cell -1, because in Common Lisp you have to count from 0. And now I will generate some index value with random number. I generate n cells value between 0 and no max. So here I have some number. And with the function substitute map, I will substitute to this index value, I will substitute the content of my, the according content of my length reservoir. So here is my length. I can do the same for 7 parts, rhythmic parts. So now we need some pitch contour. I call that pitch contour because we will remap these pitches. So that's not really the final pitch we will use, but just some contour ready for the mapping. So for the pitch contour, I generate PCH1, and I'm using a white noise. Something like that, but smooth, so with a vector smooth function. So something a little bit smoother. And I will convert this to pitch between C4 to G5 with a function vector to pitch. So I have a noise, smooth the noise, convert to pitch, put in variable PCH1. So I will get some pitch here if I evaluate this. So I have a list of pitch here. And yeah, sorry, I have no sound here for my preference. I have to specify to use the internal port. Yeah, so now we will get sounds. Okay, and for pitch 2, it's just a rotation from 4 elements from pitch 1. Pitch 3 will be a rotation of 4 elements, but from pitch 2, so it means 8 elements from pitch 1 and so on. So a kind of cascade of rotation. Okay, so this is my master pitch line, and I generate the other pitch contour from that one with rotation. Now we will need some articulation. So for the articulation, again, I create a reservoir, but this reservoir is made to match the length reservoir here. I mean the articulation I wrote here make sense according to this rhythm naturally. Because my idea here is to use the same index value I used to call the rhythmic cell in a certain order. I will use the same index and to call the corresponding articulation cells for each of these rhythms. So there will be a perfect match between rhythm and articulation. And as you can see for the rest here, I'm using nil here. This is an important detail. So now I have my articulation, and I use the same technique of substitute map, but from the index I use for the length generation, but that time I substitute the articulation. And I generate again 7 lists of articulation. So we have some rhythmic stuff, some pitch contour, some articulation. We need some dynamics. So for the dynamics, I generate again a kind of reservoir. Maybe I have to put nil here as well. And this dynamics again use the same technique they will correspond to my length index, always using substitute map, but this time on dynamic reservoir. So this corresponding to this articulation and corresponds to this rhythm and so on. Now we have to assemble all this material in OMN. OMN is Opusmodus notation. Let's do that now. So I have a first variable OMN1. I'm using the make OMN function from Opusmodus to assemble material, and I say for the pitch I use PCH1, for the length 1, velocity dynamic 1, and articulation art1, and so on for each of the 7 lines. Now we will add a bit of transposition to be, for each instrument to be more in around the tessiture of the instrument. So, and it's a parameter we could tweak later as well to obtain some certain effect. So now I'm declare the variable omn1 point t for transposition. I transpose to 0, no transposition for omn1, but because the parameter is here, at any time I will be able to change it when I will work on my composition, but for now let's keep it at 0. And for each of instrument I specify transposition. For example, here you have the cello, so it's minus 24, and the left hand of the pianist as well. So this is the transposition. And now we will do the mapping. The mapping is, we will map all this pitch to the, we will map a harmonic structure to all of this pitch. So we will first generate the harmonic structure. So here is my set, SACHER set, you know, S, A, C, H in German, E, and R, SACHER. This will be the basic material for our piece, harmonic material. So I will generate some chords from that. I'm using pitch transpose random, and inside that set, SACHER, I will transpose to 12 minus 12 or plus 12, 3 pitches. We have 6 pitches here in this hexachord, and I will transpose 3. So if you look like that, we can get something like that. I will chordize the result. I will repeat this process 8 times. And I will use pitch transpose start, and all these chords will have a basic start transposition on E flat. So this is my chord. Now I'm creating an harmonic path with the function tonality series, and I pass to the function the chords. Actually, I keep the mapping on nil, but it could be very useful to read the documentation of tonality map and tonality series because there is many options, and you can do many things with this fantastic function. But let's keep it the map on nil actually, this parameter, that's the basic mapping. And I will create a variable harmonic rhythm with 2 whole notes, so 8 bits basically. So the harmony will change every 8 bits. So now we have almost everything. We just need to do the remapping. So let's do it now. So omn1 point M will be the new mapped line. So I'm using tonality map. I apply path. We design the harmonic path here. I apply this path on OMN 1.T and that line. And the time, it means the harmonic rhythm of this is specified here with this variable and on the optional parameter time. So I'm generating the 7 line with the mapping. And now maybe we have to distribute to instruments. So in place of pause, we will replace by the material, and I'm adding ambitus control for each instrument, ambitus clarinet, flute, violin, and so on, just to ensure everything will stay in a possible tessiture. So now let's try our small algorithm. Evaluate score to notation. He actually do the mapping, the score. So interesting. Well, we can change a bit the zoom. Once you have that, naturally you have some things you can play with. Maybe we could add, for example, a pitch ornament on the material generated. So pitch ornament will just ornament all repeated pitches. Actually, I don't specify any interval in the function, so this is the default interval. If you look in the documentation, I click on pitch ornament and press Command D, and I have documentation here, and you can see the list of interval used by default, but we could change that naturally, but let's use it like that. So we can again evaluate that part. And see what is the result with pitch ornament. So that's all for today. Happy Opusmodusing. Bye.